Hey there. Let's listen to the global voices in drones and development. These are a series of masterclasses, interviews, and discussion on the use of drones and drone based technologies for sustainable development and social impact. So let's get started.
Great. So, hi everyone. So, I am Vibhu. I'm the co-founder at Vizzbee. Today, I'll be more or less talking about, enabling high-density airspace operations using drones. Uh, and before that, I'd like to tell you a little bit about myself. So, of course, being a co-founder at Vizzbee, we have a startup that we are working on making our airspace more safer and more equitable to and more fair to everyone. But I am also an open source enthusiast. So, I totally believe that open source technologies can accelerate this industry and accelerate this whole ecosystem. And it is very much required for not only for, small startups, but even for larger corporations so that, they can coexist in this whole ecosystem. So I'm also, one of the PX4 ambassador, which is under the Drone Code Foundation, and one of the community manager at Aerobridge. So we'll talk about that in a moment. But I'd like to focus. My talk would largely revolve around why do we need cellular connectivity for drones, and I know there are a lot of there has been a lot of debates around this thing. But my topic of concern would be more for drone operations in urban environments. So this is not focused for drone operations in remote environments or remote regions where there is no network coverage, but this is more in urban environment where there can be high density airspace operations and drones carrying out autonomous missions and search and rescue responses and package delivery and so on. So of course, we know how cellular connectivity can help the drones with long range connectivity and low packet data loss, high data bandwidth, and using although NPNT is not there, but if in other countries also, you can using cellular connectivity, you can get real-time airspace authorizations and also real-time deconfliction with other aircraft. So this is why I believe cellular connectivity is a must for operating drones in high density and mostly in urban environments. This has also been recommended by 3GPP. So if you look into 3GPP is the industry body which lays down standards for all the telecom, all the generations of the telecom, even 2G, 3G, 4G, all the standards had been laid down by the 3GPP global initiative, and they have also recommended this network for operating drones and connecting it to the UTMSPs and the unmanned aerial traffic management system and also the flight information management system. So uh, uh, also we are one of the few companies who have been selected by the government to participate in 5G trials. So I'll also highlight why do we actually need a 5G. So let's say we the first question that we usually get for operating drones and in cellular network is the coverage that is the network issue. We all know that these telecom towers are directed towards the ground object. They are terrestrial networks. They are not directed towards the aerial heights. That you won't be getting a good coverage at a height of about, let's say, 120 meters. So for that, what we are developing is we're developing open standards that in case the drone goes out of the network zone of any 5G or 4G tower, it can use any drone port to again connect to the same network and transmit all its telemetry data and all the video feed back to the network. And this is all being done using open standards. I'll talk about that in the end. So this is all being done using the open standards that we are developing. So almost every drone that is out there can connect to the internet if it's flying way above, let's say, 70 meters or higher. Uh, the other thing is we don't actually need 5G for uh, you know for throughout the mission. Uh, we And 5G is definitely, it's a short range. It the 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 signal intensity drops significantly with the distance for 5G as compared to 4G. But yeah, at lower altitudes, especially during takeoff and landing, I think higher autonomy is required for drones. So 5G would be a better tool for these aerial vehicles. And for higher altitude, when the drone is just going in a straight line where there are not much obstacles, then at those altitudes we can rely on 4G for the connectivity and sending the telemetry data back to the UTM systems. Yep. So I'll talk about a little bit about 5G and 4G. We have been doing trials with two of the major telecom companies in India. So what we have observed is, what we also did was we offloaded some of the compute power to one of the multi-edge compute server for we just offloaded the compute to the multi-edge server in the low latency network. So what using this, we don't actually require very high sophisticated uh, companion computer sitting on top of the drone and increasing the weight of the drone. We can offload some of that AI and computer vision algorithms to the MEC server, and the MEC server would be directly sending the set points and velocity commands back to the drone. Since the 5G has latency of less than 10 milliseconds, and that is very significant for the drone to operate. The second and the most important, as per me, is the centimeter level accuracy using technologies like ECID and OTDOA. So, you might have seen in the previous sessions, we were talking about drones for mapping purposes, and for generating orthomosaics and high resolution satellite imagery and even digital surface model, you need centimeter level accuracy of the GPS. So what the surveyors do, they rely on RTK and PPK technologies, which are quite expensive. But with 5G, if we use these two technologies, which are in the 3GPP standards as well, we can get centimeter level accuracy without any of those base stations, any of the RTK or PPK based technologies. So this can be a major a huge game changer for mapping industries as well. And also, of course, for carrying out package delivery operations, if you want the drone to land at a centimeter level accuracy, deliver packages at centimeter level accuracy, then also 5G makes more sense, because GPS has an inaccuracy of about 10 meters. So to operate in very high density urban environments, it's important that we need 5G as a solution. The third point, of course, low latency, high data bandwidth, we all know. I'll come to the fifth point, which is again one of the most important thing and most interesting thing about 5G, is the V2X side link. So we've been hearing a lot about the remote ID broadcast and network remote ID and all those things. But what 5G would offer is, two drones can communicate with one another directly without their communication being relayed through the base station. So what this means is, basically one drone can be aware of all the drones that are nearby to it, using the direct side link communication of 5G. And even though those two drones are not in the coverage, they are far away from the telecom tower, not in the coverage zone, then also they can communicate with one another and create a mesh network of their own. So this can actually help drones to deconflict and plan their own trajectories in case of any emergency as well. Let's say there's a power failure or telemetry link loss failure in one of the drones, then also it can communicate its information back to the main station that this and this problem has occurred, and it wants to perform an emergency landing at the nearest drone port. So this can only be possible by the V2X side link. V2X is basically vehicle to vehicle, vehicle to infrastructure, and vehicle to the network. It includes all the three verticals. And 5G also has less interference. So all the drone experts in this call might be aware, if you just switch on the DJI Phantom and DJI Mavic inside a room and there's a Wi-Fi router around you, most of the Wi-Fi routers stop working because of the high interference produced by these drones. And just imagine, hundreds and hundreds of drones flying in the airspace, how much interference they'll be causing. All our Wi-Fi would stop working as soon as a few drones are passing by your home. So that's definitely not a good viable solution. The better solution would be using cellular network. They offer less interference, although they do offer interference, that I'll cover in the next few slides. But as compared to the typical drones that we use, compared to them, they have a bit lower interference. Then coming to the strength versus altitude. So we have carried out test in Chakan in Pune, where, which is one of the testing locations for 5G. And what we found out was, at an altitude of somewhere around 30 to 40 meters, we got actually much even better coverage than compared to the coverage at the ground. But as the drone increase, as we increase the altitude, as we went up to like 200 or 120 meters, the signal strength dropped significantly. So although this won't be a major problem in the future, because telecom companies can just adjust the antennas of the telecom tower to have a better coverage at even higher altitudes up to 200 meters. But yeah, as of now, this if we want to use LTE or 5G for your application, then this will be a challenge. The other few challenges are the serving cell selection optimization. So as the drone goes at a higher altitude of, let's say, 60 to 70 meters, it has more number of telecom towers to choose from as compared to what we have in the ground. So and the most of the algorithms that are that are running on these devices that are being made by the hardware manufacturers, they are optimized for ground objects. They are mostly optimized for running on selecting between two or three different telecom towers with very different signal strengths. But at higher altitudes, this changes. The number of towers to choose from increases. It goes up to like 10 to 12, and the selection algorithms is not optimal for these drones. So we need a better serving cell selection optimization. The other two things, intercell interference also increases. The downlink interference is significantly higher because of the interference due to the nearby telecom towers as well at higher altitudes. And the third is the network design trade-off, because of course the network is mostly optimized for for the ground users. They are not optimized for the unmanned aerial vehicles as of now. So we'll need to modify these three different things in order to have better and reliable communication. The other thing, of course, the throughput. So as per 3GPP, they have recommended that for any aerial vehicle, an uplink of 100 kbps and downlink of 4 Mbps with a latency of less than 50 milliseconds, and packet error of lower than 0.1% is a good thing. Anything less than this would be good enough for a drone to operate. And in our testing, 5G was way too much better. We achieved and the latency was even less than 20 milliseconds. And talking about speed, it was in Gbps. The downlink speed was in Gbps, and the uplink speed was somewhere around 200 to 300 Mbps, which is good enough to even stream the 4K, the 4K videos back to the command control station or the remote monitoring stations. The terrestrial network, since I talked about, they have these down tails. They are currently optimized to serve all the ground user equipments. But yeah, in case the number of drones increases, and there's a huge market potential for these telecom companies also to cater to, once there are more number of drones, will have uh, these towers serving the network at a higher altitude as well. So this won't be a problem, let's say 2 to 3 years down the line. And yeah, so 3GPP has also been working on this very effectively. They have carried out tests on their own, and they have been creating standards, particularly for drones, and how drones can be integrated with the telecom service, uh, the, the cellular networks basically. And also they have been working with other technologies, like I talked about, the ECID and OTTOA and the positioning services offered by the cellular networks. So as of now, we already have release 15 and release 16. We in the next few years will be having release 17 and 18 as well. And by then, I think we also be carrying out, we at Vizzbee will carrying out few more trials. And I would like to say that all the trials that we'll be conducting will make everything open once the trial is done, so that they can, all the information and all the the findings and all the data that we collected, that can be utilized by other companies to optimize their drone fleets, and also for better policy making in the directorate side as well. So yep, the antenna problem, of course, I think I've already talked about this. uh, Yep, I've talked about this. So what are the next steps? So the next steps would primarily involve around industry participation in open source technology contribution. We need more participations in developing standards and protocols for these drones and the different UTM ports, and not UTM ports, the drone ports, and the UTM SPs to communicate. We need more technologies and industry contribution on those domains. The second thing would be also participation of academic institutes, because not just cellular, I mean a lot of startups and a lot of drone companies in India are facing some challenges or the other in terms of hardware, having better propellers, having better motors, and having better materials. So if some of these can be translated into, if is propagated to these academic institutes, then it will be very helpful. And also forming open consortiums and the TCL trials with the latest technology, so that by open consortiums, I mean carrying out these high level operations and high density drone operations, and also the concepts of advanced aerial mobility. If we can conduct these trials together and also make these data open to the public, so that other communities can also get benefited, and also that can be utilized for better policy making, I think this will accelerate this whole drone ecosystem. The fourth thing, I think we should all come together. So at Aerobridge, where I'm one of the community manager, we help different companies to develop some of these standards and some of these technologies for free. So we also have this open source management server, which startups and companies can deploy free of cost. We this is just a community service, just like Ruchi and Flying Labs and V Robotics are doing. We are just but we are more focused on the tech side. We help small companies to have technology level compared to to the other bigger companies as well. Yep, so that's it. Also, I'll just as a knowledge session, if someone is interested, how to configure their drone with the 4G LTE or 5G LTE, and use some of the software, I'll be just feel free to reach me out. I'll be happy to help. I'll be we usually make all of our software and the technology stack open, so you can use it to make your own drone Internet of Drone platform or anything. So yeah, thank you so much. Any questions?
Thank you for your amazing presentation. We have Okay. So the session is open for Q&A. Please put your questions in the chat. Until then, I have a question. Generally, as we know, as the frequency increases, we have a drop in the range. So we are talking about 4G and 5G. So in those terms, generally the range is termed to be less if we don't have a intermediate or a very immediate radar or a very intermediate source nearby. So how can we tackle that thing?
Yep. So, we also face the same issue during our trials, both with 4G and 5G. But the solution here would be using a heterogeneous network. Like I talked about, in case the drone goes out of the network, it can still communicate with other drones using the V2X link protocols. And also, if the drone is equipped with network remote, not network remote ID, if the drone is equipped with broadcast remote ID and there is any drone port nearby that support one of our open standards, so the information of the drone will automatically be fetched and uploaded back to the internet, so that the owner of the drone can still be aware of where the status and the position of the drone. So this is what we are also developing. We have already done a few trials. We have partnered with a few drone port companies in from Europe, and we will be also sharing videos and details regarding that very soon, and by next month.
Okay, thank you for the answer. And then another question is, let's say we are talking about 4G and 5G, then there are few restricted places where nearby we have 4G and 5G radars, like not radars, that are jammers, and these frequencies are not pretty strong there. And even if we are talking about suburban areas, then 4G is still not very much like standard there. Then at those places, what is the fail-safe or what is the countermeasure that you use?
Yep. So, I totally agree. As I've told in my initial presentation, so this was mostly for urban environment. I know that, even we have faced challenges when we, went to fly in remote areas. Dr. Ruchi might also have face the similar issues when you go to deliver these emergency response packages in remote areas. There isn't much coverage. And that is still an issue that we need to figure out. And you know as of now, I don't have any answer. My presentation was more focused on for the urban environment, but yes, maybe we can uh, get more feedback from other people and maybe some experts on how to solve those, work on those lines. One solution could be, work if we can work together with some of the telecom company providers. So because some of the drone corridors will be fixed, the drone will be following the same trajectories in the remote areas as well. So these telecom companies can ensure that the networks remains throughout that particular drone corridor. And although this I'm not sure about the economic viability of this thing, but yeah, if there are enough number of drones flying in that particular corridor delivering packages at a remote location, then of course this can be one of the solutions. Yep. Any other questions? Any other suggestion or feedback? I'm open to anything.
Yeah, one question from me. Hello, can you hear
Yes,
me?
please. Yes, please go ahead.
Yeah, okay. You mentioned that the 4G network, as I mean, it is meant for urban area and low altitudes, right?
Yes.
Did I get it right? Okay. Now, as you know, most of our missions, I mean, be it for surveillance or be it for logistic deliveries or any purpose, I mean, we have to fly at a minimum altitude of 100 meters in urban areas just to clear any kind of construction obstacles or anything for that matter. That is a minimum of 100 meters. So if you're flying at 100 meters, I think the 4G network, what I saw, I mean, one second. I I think I did take a screenshot, but okay, anyways, I think it drops considerably, right, on the 4G.
Yes, absolutely. So at 100 meters, although we do get a decent connectivity that the drone would be able to share its coordinates to the server, but it's not good enough for streaming 4K high resolution images. We got somewhere around 95 minus negative 95 decibels at 110 meters, and that is quite decent. But yeah, anything but going above 150 meters, the signal strength dropped very significantly. It was almost zero.
Got it. And
yeah,
sorry, and this you're talking of 4K. What if you're going? What if you're doing only full HD 1080?
Yes, full 720. I'm not sure. We have tested it with 720. 1080, I think. We at 1080 at 30 FPS is still challenging, but yeah, 720 at 30 FPS is doable even at 100 meters. And also, just to let you know, the network strength depends on area to area. So if you are living in a metro city where there are high-rise tall buildings, then of course you can get good coverage even at 150 meters. But if you are in tier 2, tier 3 cities, the signal strength drops significantly even at 100 meters. So that also depends on where you're operating the drone.
Understood. Thank you.
So I guess there are no more questions, and if there are more questions, we can move them to chat.
Yep, sure. And if you have any questions, you can just reach me out. Anyone, you can reach me out on, I think I don't have my contact here, but I'll post my contact details on chat. And also, if you are technically oriented, do join our Slack channel. You can post any questions. We'll be happy to help you out and have the best technology standards, and that too free of cost. So yeah, thank you so much.
Thank you so much, Vibhu, for being a part of our conference. And what I know is you are one of the most popular drone professionals in our country, and you have a great following just because of all the amazing work that you do. I really hope that you keep continuing and keep inspiring us, and look forward to working with you.
Thank you so much, Ruchi, for the kind words. And likewise, you're also one of the most popular, and thank you so much for bringing us all together and organizing this conference, and being the forward face for drones for good in India. So yeah, thank you.
Hey there. Thank you for listening to Global Voices in Drones in Development. We will be releasing at least one new episode every week, and that would be on a Saturday. So please do tune in. And you're most welcome to join the Global Alliance on Drones in Development, where we would be having podcasts, videos, masterclasses, meetings, discussions, and much more. So see you around. Thank you for listening.